Okay, information retrieval LS574 online information retrieval. Today we're going to explore some of the concepts on information retrieval. I think it's always good to have a theoretical background. We have seen some databases, and we're going to next week and the following weeks we're going to work with specific databases. By the way, I have an exercise later on the Science Citation Index, or not an exercise, an exploration that I'm going to show you after the break that we will be very interesting, because we'll see some comment-driven comment-driven advanced search in the Web of Science. But today we're going to talk a little bit about theory and about concepts, models on information retrieval. Please bear with me, because this semester has been very bad for me, because I've been suffering of cold, and I think flu and cold and flu, and so I never get back to my own self. So one of the things we're going to talk today is about the traditional information retrieval model, the major concepts and definitions, as I said before, system and user components, exact match and best match searches, strengths and weaknesses, interactive information retrieval, definitions of IR interaction, interactive IR models, and implications. Why do we have to learn IR, information retrieval? Well, every online database, every search engine, everything that is searched online is based in some way or another on principles developed in IR. Information retrieval is a discipline within the information science, and there are experts who do research on academic research and experimental research on information retrieval. Information retrieval is at the heart of searching any of the systems that we are exploring this semester, and any system that you will encounter in the future. Understanding the basics of information retrieval is a prerequisite for understanding how searching of online system works, and I think we have done some of it this semester in terms of talking about indexing and we have explored some databases that I show you how to use the thesaurus and so on. It is also important, and I always like to make emphasis that we have to get familiar with each database, each academic database or information database that we use, either bibliographic database or a full text database. In any case, we have to get familiar with each database, go to the help file to see that database, how can we do search. As an informational professional and librarian, it is necessary to understand how a system works, which will be helpful to understand how information search can be conducted effectively and efficiently. Okay, first let's see what the definition of information retrieval is. The process of actively seeking out information relevant to a topic of interest. And of course, this definition applies to it's a very general definition that applies to every model of information retrieval. If we seek information, relevant information, and that's, I think, it's the key word here, relevant information on a topic of interest. Typically it refers to automatic rather than manual retrieval of documents, and by that we mean when we use information systems, when we use information databases, not when we go and retrieve information from a book, for example, though that is also considered information retrieval. But in general, I think the idea of information retrieval have to do with automatic search, online, can be online or not, but through the use of an interface or databases and a computer interface. Okay, so when we talk about, we, of course, human beings, in the story of human beings, we always been searching for information relevant to solve our needs. solve our information needs. This is from the beginning of us as a species. So that hasn't changed. Now, of course, we have automated we have automatic systems. We have computers, we have the digital world, and of course we have online searching too. So this concept or this idea of information retrieval has become more relevant each day. The other problem that we have to remember, and I like to emphasize that, especially to all my library students, is that today the problem is not anymore that we don't have access to information. That may still be the problem in some areas, in some places where there is a lack of access to information. But in most cases, the problem that we're facing today is that we have too much information. Too much information that may or may not be relevant to the needs of the user. So we as as librarians have to be aware of that problem, the information glut, the information overload. Okay, again, please, I hope you forgive me, but that's why I didn't record a lecture last week, because I couldn't, but I'm still suffering of this coughing and congestion. What is information? Data versus document retrieval relevance. I think when we talk about information and we think about when we define information, we may say that information is data with a meaning, meaningful data. When we see a piece of data, a number that doesn't have any context, it doesn't have any meaning. But when we see that data on a context, on a report, it becomes information because it's offering us meaning. Okay, we may do data retrieval or document retrieval. When we do document retrieval, that's what we do most often. Of course, we are retrieving information. And relevance is another very important concept, because what we are trying to aim at is to retrieve relevant information. Data versus document retrieval. Data retrieval is specific information data requested in the inquiry. Document retrieval is more ambiguous, usually refers to retrieval the description and address of one or more documents. And what we're aiming at is at document retrieval. Document is a generic term for an information holder, book, chapter, article, web page, etc. So this is a document retrieval. We're not talking about a printed document with pages and text. We're talking about a generic term. Okay, and please take that into consideration. Now, relevance can be defined as how pertinent information is retrieved from a certain system, which can satisfy the user's particular needs. Okay, can be defined and how pertinent information is. Relevance judgments occur as individuals evaluate surrogate language such as index terms and abstracts. That's what we mean by surrogate terms, and how they evaluate and use the documents retrieved. And there are two ways of approaching this. One is the system approach, and the other one is the people-centered approach. In terms of the system approach, is system-centered approach dominated early study of this phenomenon, information retrieval, and they use metrics as precision and recall to assess the likelihood of retrieving relevant documents from a database. So it was from the perspective of the system, not from the perspective of the person or the information seeker in the past. That has changed now. Information retrieval studies also mean that again, information retrieval studies nowadays focus on the people, on the user, on the information seeker. And here we have a graphic here of all the documents retrieved, all the documents, and this is we can see that as the whole as the rectangle, then retrieve, and then what are the relevant documents. Okay. Here we have a distinction between precision and recall. Okay. So precision, it's those documents that are in that we retrieve that are relevant. Relevant retrieve is this this area here, okay? And recall is documents retrieve in comparison to the collection. Again, precision, it's documents retrieve in comparison relevant documents in comparison to all those retrieved. And recall is relevance retrieve in comparison to all the documents in the collection. Okay, so that is the difference. Of course, what we are aiming at when we do when we care about our users is precision. Okay, because we want to see is relevance retrieve within the retrieve group. Okay, so we have all three groups here. We have all documents, then we have the retrieved documents, and then the relevant documents. The problem here, and this is something that we have to understand with precision and with recall, is that there may be other documents that are relevant but are not retrieved. You see, in the group all documents, there are some documents that may be relevant for our information needs or the information needs of the user, but somehow they are not retrieved. That's why we have to understand that we may have to use, for example, control vocabulary. If we go back to last week, we talked about control vocabulary. We talk about the use of thesaurus, okay? But, and this is something that we learn as indexers. If the work hasn't been done well when we do indexing, for example, then it will be very hard to retrieve that document. And that document may be lost forever. So these are concepts that we have to think about and we have to play about, okay? And we have to become proficient online searchers. Okay, relevance. User-centered and included cognitive and interactive studies in information retrieval to help explain users' relevance evaluation. And here we have some studies and some models too. Here, relevance criteria were related to the characteristics of the query and the individual. To me, these are more relevant, and let me say that word, to us library scientists or librarians. Later, this concern expanded to include recognition of important situational elements in the retrieval environment: the organization, social domain, the individual, and the cognitive complexity of a human working for an organization. And we have here more studies. This is for your knowledge here. We'll take a simple view in today's class. A document is relevant if it is about the searcher's topic of interest. So this is a definition in the context of this class about relevant. A document is, and let me repeat it again, a document is relevant if it is about the searcher's topic of interest. What do we want from an IRS system approach? Goal: for a non-information need, return as many relevant documents as possible and as few non-relevant documents as possible. You see, here it is very interesting, because when we do a search, an information retrieval search, what we are trying to get is return most relevant documents as possible, but at the same time we want to retrieve as few as possible, as it is possible, non-relevant documents. And from a cognitive approach, the goal is in an interactive information seeking environment giving an IRS support the user's exploration of the problem domain and task completion. So these are two approaches to information retrieval. One, of course, is a systemic approach, and we're talking about documents and we're talking about numbers here. We want to retrieve as many relevant documents as possible and as few non-relevant documents as possible. And from a cognitive approach, we have a goal, and the goal, of course, is task completion. Okay, what questions IR addressed? IR is aimed at providing the users with effective access to and interaction with information resources. Here are the questions IR addresses. 1. How to organize information intellectually. 2. How to specify search and interaction intellectually. 3. What systems and techniques to use for those processes. IR is a big topic in information science. In this class, in the context of this class, we're going to focus on number 2, how to specify search interaction intellectually. As I said before, information retrieval is a specialty within information science, and there are many and very well-known information retrieval scientists. So it is a specialty. Now, in practice, the focus is on different aspects of information seeking process depending on the researcher's background or interest. For example, these are examples. A computer scientist will focus on fast and accurate search engine as a computer scientist. A librarian, we're going to focus on organization and indexing of information. In the cognitive scientist, the process in the the process in the searcher's mind, and the philosopher may ask, is this relevant? Okay, and of course these are from the perspective of a researcher and a discipline. That's what a researcher would ask. Okay, if he's computer science, he's concerned about fast and accurate search engine. A librarian would be concerned about organization and indexing of information and control vocabulary, etc., and also about precision and recall, and also about relevancy too. But these are like examples. Progress influenced by advances in computational linguistics, information visualization, cognitive psychology, and HCI, which is human-computer interaction. Models. Information retrieval models. A model depicts and represents what is involved, which include features, process, things during information retrieval. And there are many models of information retrieval. There are several IR models used over time, including the traditional model. This is the oldest and the most used one, and shows the basic elements involved in information retrieval. And I think we have some models. We're going to show some models now. And the interactive model, it is more realistic in depicting the IR process. It shows also interactions involved, and it is favored now. However, each one has strength and weakness. There's not a perfect model. And of course, remember that a model is a conceptual representation of reality, but it's not reality. Okay, we cannot expect any model to be as complex as reality itself, because it wouldn't be a model, it would be reality. Okay, a model is what we call a theoretical construct. It's a theoretical construct. It's a piece of theory. Here we have the traditional model by Bates. Here's the classic information retrieval model, Bates 1989. You can see it's very simple. It involves only 5 elements. And here's a question for you. Can you describe IR process based on this model? Yes, you may. You may try. We have an information need. We have a query. We have a search here. This is in this part here and here. Okay, let me see if I can outline this. Then we have the document representation, remember, and this is very important. Every time we search a database, of course, we are seeing what we get in our search. What we retrieve is the document representation. It's not the document itself, okay? And then finally the document. So I think this is a very nice working model of information retrieval. Now here we have the stages of information retrieval, and we have creation of information, of course. And I don't know if I have shown you the cycle of information. I'm going to check on the DT2L side to see if I have talked about the cycle of information and also about data, information, and knowledge. But we are all creators of information, by the way. Okay, we all are. So we have to take that into consideration. We are not only consumers of information, though we may that may be what we are for the most part, but we also are creators of information. And that information, of course, in order to be retrieved, and this is the key, and this is what it ties everything up in our profession, because we have to see our profession as a whole. We cannot see it as different things. We have to see it. We cannot see it as different courses. No, my teaching philosophy and my perspective is a holistic perspective. And when I teach, I try to convey the idea that information science and library science, it's a totality. Okay, it's not courses, separate courses. It's a totality that we have to understand. So we create information, we consume information, but in order to be able to retrieve that information, it has to be processed. And by process, I mean it has to be organized. And that's why we have indexing, that's why we have cataloging and classification, and that's why we do database, and we have a record with fields, etc. Okay? So information has to be indexed and organized, and it has to have a structure. And if we go back to what we studied in the prior weeks and we saw the bibliographic record, we saw that the bibliographic record had different fields. And I asked you, or the book asked you, about how did a bibliographic record or a database record look like, because it has a structure. Okay, and then of course we have, once we have created that information, we have processed that information, then we have searching that information, because we want to retrieve that information again. And the best way to do that, of course, or not the best way, once we have that information recorded in a database, or the representation of that information, remember that's a key to the representation of that information, then we want to retrieve that information for our information needs or the information needs of our users. That's what we are seeing here in the stages of information retrieval. So information retrieval studies the whole phenomenon. Here, let's see what it says here, traditional IR models. Here's what the model describes. Imagine you have a pile of documents and you represent the documents by surrogates. You see, it is a representation of the documents: index terms, abstracts, fields such as author, name, etc., etc. Those are not the documents themselves. Those are representations of those documents, and we call that surrogates, and store them in an IR system. That IR system is a database. Imagine a bibliographic database. Imagine one of the database providers, for example, as EBSCO, Wilson, and, Web of Knowledge, etc. And imagine one of the database, information science database, abstracts, for example. A user has an information need or several needs. She or he goes to the system and formulates a search query and submit it. This is the user part, of course. The first one was the system. This is the user. And then the algorithm that it's programmed into the system compares the query with the representation of documents. Again, here the keyword representation, based on some rules: exact or best match or proximity. Remember when we were talking about databases last week, and we talked about wildcard, proximity? Well, this is what we're talking about here. So this theory has a practical counterpart. This is what we are trying to convey in this course, that you have to understand this theoretical part in order to become a proficient searcher. But of course, the idea is that you have the practical tools such as proximity, wildcards, Venn diagrams, operators, field search, etc. Okay? And a set of search results whose surrogates match the user's query is returned. This is what you retrieve. Okay, the formalized IR process. Okay, here again it is the same thing. It may look a little bit different, but we're talking about the same thing. This is another model here, and we have here we have documents describe events from the real world. They are holders of information. In order to be stored in a computer system of future retrieval, documents need to be processed and abstract document representations will be derived. Okay, so you have real world here, you have the creator of information right here, then you have a collection of documents, then you have to process those documents, such as doing indexing and giving the document a structure, and that's a document representation. Then on this side here you have an information need, you do your query, and following an algorithm about exact or best match, for example, you get your results. Okay, this is it. This is information retrieval. Traditional information retrieval, the components, specific components of ER. We talk about the system, we talked about the user and match mechanism here. This is the system part. The system part is our database. Okay, here is the user part, information needs, and how we're going to solve those information needs. And here is the other component, and these are the mechanisms, the match, okay, and the algorithm. So this is what this is. Okay, let's see this in detail. System, content, what information is stored in a database. That's very important for us to know. That's why I always encourage you, and I think the textbook does that, to explore the databases that you have available through Clarion EDU, and we will do that. I will do that in future presentations. Representation, how the documents are represented in a database. That's another key that we have to understand. What fields are represented, what fields are indexed, which fields are access points, which ones can you use as to search information for. Okay, and depending how you use those tools available to you, you will have more precision or more recall, or both. We need to understand how the database is structured. I think that is very important, and I think we have seen some examples of that when we study the bibliographic record, for example. How file is organized in a database, and if you go back, we talked about that before. We need to know how indexing procedure is done in order to represent documents, and of course, think about an index. The most basic index is what we call back of the book index. Okay, and the idea of the back of the book index is that you can find information within that container of information. But in terms of serial index, once you have an index term, it will search the whole collection to see which articles match that index term. And the interface, and that of course is very important, the user interface, or the search interface, and the result display interface. Okay, so these are all elements in the system that we have to get familiar with. And then we have the user. Users have their information problem, of course. If you don't have an information problem, why are you looking for information? You have an information need. You want to solve a problem. These problems have the following features related to task situation in hand. You have a task that you have to resolve. Vary in specificity and clarity. Produces an information need. Information need for the same problem may change, evolve, and shift during the IR process. And this is very important. And again, here comes my holistic way of looking at librarianship. I also teach the reference class, and maybe you were one of my students. And something that we have to do when we do reference is to refine our query. But not only because we want to have better precision or more recall, but because the information needs of the user may have changed or may have evolved. Okay, so take that into consideration too. So as you can see here, we're talking about information retrieval here, we're talking about database design, and we're talking about reference too. And indexing and abstracting, of course. User transfer their information problems to some specific question, and not only question, to their specific situation. So non-mediated end user alone. Now many end users do this by themselves. You look for your own information. And mediated with an intermediary. Of course, who is the intermediary? You as the informational professional, or other users. You know, they may use that, but normally, of course, we're talking about us as professionals, and we are the informational professional. We are the librarian. We are the informational manager for that user, for that information seeker. Then analyze the question, select search terms, and here this is reference 101. Okay, this is reference 101. When you're doing reference, you of course and you are approached by an information seeker, you interview that information, the reference interview. At the heart of the reference component, there is a reference interview, because we want to know as much information as possible in order to help our user. And we have to have the questions, and we have to ask the questions in order to understand the information need of our user, what our user is looking for. And once we have and understand his information needs, we have to select the search terms. And how do we use this? How do we do that? Well, we may use natural vocabulary at the beginning, but we may use a thesaurus. Okay? Why? Because we want to be more. We want to have more precision. Remember to use and when I say a thesaurus, I'm talking about control vocabulary. So we go to the database as I showed you the other week, and we look at the thesaurus and see what are the control terms that are used in the database to index the information, or even better, to index the representation of the information. Okay? Users can use different search tactics or strategies, I guess, to pursue their search goal. Different search tactics will have different effectiveness. Here it says we will discuss this. I don't know if we discuss that. So let me take this off here. Again, this is an interactive, iterative process. For many users, and lot of search topics, and it is necessary to search several times in one search session. Okay. What it means is iterative process. What it means there is you have to build upon one search, then you do another search, then you are doing another search, because you're refining your search. And again, not only from the informational professional point of view, but from the user point of view, because new questions may have arisen. Now, in terms of match, the process is out of control of searchers. Why? Because there is an algorithm there. The algorithm, here it is, that you don't see and you don't know, decides what documents in the file match the query as stated. In the file match the query as stated, you see? There are various search algorithms. For example, exact match based on Boolean algebra. We already talked about that. We're not going to talk about it later. Best match is ranking by relevance or other criteria. That's what they do in Google, for example. And hybrid incorporated both target rank in dialog. You will read those comments later. Okay, we'll see those comments later. But I think the best, not the best, the most used ones are this one. This is what we use in when we do search in academic databases, and this is what we use. Well, this is the algorithm that when we get results in search engines. Why call exact match, since you retrieve exactly what you ask in a query? All documents are returned from the system that have the terms with logical connections and possible other restrictions, as stated in the query. Exactly, nothing less, nothing more. The output is not rank, but based on some other way. Of course, we don't know what that other way is because we don't know the algorithm. Based on matching rules in Boolean algebra. And we discussed already Boolean algebra, so I'm going to take this off. The thing is, I had this lecture prepared and it was from the beginning, but I changed the order because I thought it was better to do it in the middle of the semester. because now we know what Boolean algebra is, and we know what field search is, and now we know what a bibliographic record is, and what is the structure of the database. So I changed the order. Okay, we're going to see the best result in the first place. Google is the best example. When you search Google, the output is in fact rank, not as the output based on exact match, but it is rank. You retrieve documents rank, and here's the clue: by how similar they are to the query. And they, of course, this is calculated by this algorithm, by this formula, by the system. Most of the time, similarity assumed as relevance, but as I said before, Google is based on page rank, not relevance. So they do, when you search Google, the assumption is that similarity is relevance. But again, and it is stated here, Google is based on page rank and non-relevance. And what it is interesting is that we don't know the algorithm. Usually the output is rank from highest to lowest relevance to the query. Of course, this is determined by the system. It's not determined by you. It's by the system. If you change the query, the system changes rank. Those documents as answer are presented from those more likely relevant downwards to those less likely relevant. This is a convenient for you to make relevance judgment. The output can be cut at any desired number, for example 10, because you don't need to go through every document to see if relevant or not, because they are ranked. Here is another approach. Here's to best match probability. This approach compares a set of query terms, for example two terms, with a set of terms in documents. Then the algorithm calculates similarity between the query and each document based on common terms and other aspects. This system sorts the document in order of similarity. So here's not page rank, but similarity. This approach assumes that the higher ranked documents have the probability of being relevant. It also allows for a cutoff at a chosen number. So here we have two strategies. Then again, this is made by the system. You have no control on it. Here we have some considerations in terms of Boolean and weaknesses and best match. Boolean strength allow for logic, provides all that has been matched. That's very good. Weakness: it has no particular order of output. It treats all retrieved equally from the most to the least relevant, because this is what you got in your search. So the search is not rank. Often requires examination of large outputs. That's, I think, Boolean search is very effective, and I use it all the time. The idea is to combine control terms and in searchable fields. That's why I told you before that I like to use always the advanced search. Okay, and that's what really Boolean search becomes so efficient and effective. At least that is my opinion. And of course, if you add to your Boolean search control vocabulary, then you're going to be even more precise. And of course, the documents that you're going to retrieve will be more, or the representations, to be exactly correct, the representation of the documents that you're going to retrieve are going to be more relevant. Okay, best match allows for a free terminology, provides a rank output, that's very good, provides for a cutoff of any size output, does not include logic, ranking method is not, we don't know what the algorithm is. Okay, and then you have to decide when are you going to cut off, because you don't want to read the other documents that may not be relevant. Okay, and interaction is the interactive communication processes that occur during the retrieval of information involving all the major participants in the IR. Example, the user, the intermediary, and the IR system. Information retrieval interaction involve users, intermediaries, only possible if end users search by themselves, of course not, but if we're helping a information seeker, then yes, and everything in the IR system, and there is an exchange of communication. Several models are proposed, but not none as widely acceptable as the traditional IR model. All these models try to incorporate the following elements of IR: information object, test, image, etc., information system and setting, interface, intermediary if present, as explained before. Okay, if there are not other people helping out, there's no intermediaries. User characteristics, cognitive aspects, task, problem, interest, goal, preference, social environment, and a variety of process between them. And here we have Saracevic, a professor at trying to remember his university in New Jersey, but it doesn't matter. Saracevic is one of the best known information scientists that has done most of his research, or a great part of his research, on information retrieval. And here we have a model here. Okay, of course, these are very complicated models, and we go here from this. Let's go here to the user part right here. Okay, the user. Let me see if I can see. And we have a situation, we have a task, we have an intent, and we have knowledge. We have a structure. Okay, we do our query. Let's say we're doing this without an intermediary. We're doing that to ourselves. Then we have that interaction with the system, the interface, and of course in the interface what we have built in is engineering, hardware, software, algorithms, and content, of course. Okay, so in the lower part we have the computer or the system, and in the upper part we have the user and his information need. Okay, and of course there is an adaptation most of the time from the user perspective to the system, because the system it's harder for a system to adapt. And once we get the information, then we will do the information use. Let's see how they explain this model here, the stratified model. Okay, the main idea of this model is that interaction involves a sequence of processes and episodes occurring in several levels of strata and different levels of interplay with each other. Interplay on user side, and here I think this is where there is more flexibility. Cognitive, between cognitive structures of information objects and users. Affective, between users' intention and other, for example, whether the users are satisfied with the search results and whether they are satisfied with interaction with the system. Situational, between information objects, tasks, whether the information could help users complete their task work. Similar interplay on computer side: surface, searching, navigation, browsing, display, visualization, query characterization. Imagine how you conduct a search and what you need to do with an interface when conducting a search. Interplay, judgment in searching, evaluation of results using relevance or other criteria, changing the user models due to the change of situations and information need, selection of search terms, resulting modifications, after getting feedback from system. Modifications may for better search results, of course, and also what I said too, the information needs also change. Okay, a summary for interactive information retrieval. And of course, when we talk about interactive information retrieval, we're talking about, when we see that Saracevic model, the stratified model, I think what we are trying to say is that they are more dynamic than the models and the traditional models. Okay, a summary. Though several models are proposed, none as widely accepted as the traditional IR model. I think that is true. These models emphasize both user side and system side. Of course, the traditional model is more static in that sense. Okay. The other model, the interactive model, is more dynamic. Not like the traditional IR model, which considers system side more than the user side. In IR, interaction is viewed as the center part of information seeking. These models also indicate that searching is a highly iterative process. In other words, it's built upon each iteration. I don't know how to pronounce well that word, but it means building one after the other. Iterative. Query modification means you refine your query the next time around. So you're building up. Therefore, such a strategy should also be dynamic. And this is very true. And again, go back to your reference class. You have to be a dynamic search in order to help your user. Implication of these models for interface or system design as a framework for the evaluation and so on. There has been several studies conducted based on these models. Okay, the role of the IR system, a modern view. 1. Support the user in exploring a problem domain, understanding its terminology, concepts, and structure, clarifying, refining, and formulating an information need, finding documents that match the information need description, as many relevant documents as possible, as few non-relevant documents as possible. I think this is the key here when we do a query. How does it do this? User interfaces and visualization tools for exploring a collection of documents, exploring search results. Query expansion based on, and again, this is what I have been trying to tell you, control vocabulary, use your thesaurus. Okay? This is very, very, very important. And I emphasize that because I'm an indexer too. Okay? And when we index, we use control vocabulary. So the idea here is that when we process the information and we organize the information in electronic databases, we use indexing using control vocabulary, right? So when you do on the other end, on the user end, the user will do the search, but if he searches with natural language, he won't probably get to the records that are relevant. He has to use the same list of control vocabulary. That's the whole point. It is very different than when we do back of the book indexing. Back of the book indexing, we use the language of the author. In other words, we use the language that it is in the text. So the words are not part of a thesaurus or thesaurus, but are in text. That's in the case of a book. But when we're talking about serials, this is mostly about serials and academic databases, or legal databases, etc., etc. We're using control vocabulary because the terms are not to search in one document, such as a book. They are used to search in a whole collection of journals within a discipline, and different titles too. Not only one title, but remember, when you do database searching, online searching, you're searching a number of academic journals, X number of academic journals, okay, with the indexing term. There is a big difference right there, okay. Okay, of course, not all databases are equal, just as not all users are equal. So we have to evaluate the components, the indexing, the matching algorithm. Again, the matching algorithm we don't know because it is not clear to us what it is. Of the exploratory process overall, usability issues, usefulness to tasks, and user satisfaction. To me, the most important part is the last part. Okay, this is what concerns me the most: user satisfaction. Where we able to to answer or the question that the user came with to our library. If we do it and the user is satisfied, then we did a good job. Then the information retrieval system worked. Okay. But again, I think it was important in this lecture that I did in the middle of the semester and not at the beginning, because we already have worked and explored some practical from the practical point of view. So today, or this week's lecture, was mostly a theoretical lecture on concepts and processes within the information retrieval system. Thank you.